To hear that, Alyssa. Okay, let's take a look at one. How many grams of potassium hydroxide are required to neutralize 200 ml of 2 molar carbonic acid?
I don't think we have enough information.
Oh, not enough information, so let's not do it. Let's go to
No,
that.
because we don't know how many, how concentrated the potassium hydroxide is.
Maybe it was just a solid when it was thrown in.
We don't know that. So there's not enough information.
There's enough information. Don't you love it when you have a problem that you don't think there's enough information for, but then you realize there is and you can do it?
Yeah.
Ooh, I love that. Such a great feeling. It is too. Can you write a chemical equation for this reaction that occurs? I wouldn't ask if it wasn't possible. Go ahead, I'll wait for you. What's one of our reactants? The formula for it.
Potassium hydroxide.
Oh, yeah.
KOH
Okay.
plus HCO3.
Fix that.
H2CO3.
I just didn't hear you say the two.
Yeah.
Okay.
Products?
Products?
H2O.
Nice.
And potassium hydroxide.
You gotta add it too, though.
Yeah.
We could do the net ionic for these, but with stoichiometry problems, just go ahead and leave it in the full molecular. We're used to this. We're comfortable with it. Just leave it like that.
You gotta add it too, though.
The Zundals in the book, they tend to try to get you to use the net ionic, but it's a little bit awkward right now. Later on, we'll have done so many net ionic equations that it won't be a big deal. But for right now, just stick with what you're comfortable with.
Balance it.
So don't break anything apart. Yeah, definitely balance it. Does it have a? Do you have a sense that we're going to do stoichiometry, other than the fact that the word is on the page?
Yeah.
I think we're given information about carbonic acid, but then it asks us about potassium hydroxide. That has a ring of stoichiometry to it.
So,
Balance the equation. Don't try to do stoichiometry without first balancing the equation. What do we put in here?
2 KOH.
That's it.
You got it. Okay, so I like to write the information that's given into this. The question is how many grams of that, so I'm just going to go ahead and put that in there. The H2CO3, I know that there are 200 ml, and the molarity is 2 molar. If you get to this information, you say, oh man, I don't know what to do. I always tell you, when you're in doubt, what do?
Go to moles.
Get to moles. Yes. Always. Do you kind of get that idea that we have to use moles constantly? Everything that we do, we have to use moles for. So get this thing into moles. If you know volume and molarity, let's see what that'll get us. So,
0.2 times 2.
right, 0.2 is our number of liters, times 2 is how much?
0.4.
Can we get through this thing without a calculator? I think we can. All right. Now, can you look at this chemical equation, and if you know how many moles of this you have, can you figure out how many moles of that without setting up the stoichiometry?
Yeah.
How many moles of this? 0.8, 2 times as much. Because these react in a 2-to-1 ratio, however many moles of this reacts, I need 2 times that many of this. You with me? If you missed that, I'll set it up. 0.800 moles of the potassium hydroxide. Oh man, well I know moles of potassium hydroxide, all I need is grams now.
56.
Is what? 0.8 moles of KOH. Converting to grams, the molar mass is 56. Did you use a calculator for that? Just add them up. 39 plus 16 plus 1. Do the 39 plus 1 first. That's 40. Plus 16 is 56. And can we do that without a calculator?
No.
Yes?
No.
Yes.
How would we do this without a calculator?
Cry. Thanks.
I don't know. I do.
Is it bigger or less than 56?
Less.
It's less than. 0.80 is what percent? 80%. What's 80% of 56?
I don't know.
What's it about? Yeah, mid 40s.
We would have done the test mid
It's a multiple choice test. Pick A, B, C, or D. One of them is going to be in the mid 40s.
Well, what if there's like 3 of them in the mid 40s?
There won't be.
What if it?
Everything.
What did you mean by that?
Ooh.
It'll be 45 or no,
It's
44
marginally
point.
helpful.
There's 36 so the multiple choice options are.
What's another? If you don't like that whole multiplying by 80%, another thing you can do is I always recommend you can put numbers into scientific notation. That would be 8 times 10 to the negative 1 times 5.6 times 10 to the negative 1 or 10 to the positive 1, and try to work that out. Or you can take this number and make it 8/10. You can take decimal numbers and put them as fractions. That may be helpful too. I like working with fractions when I can. 8/10 times 56. I can kind of cancel that 10, make that 5.6. How do you like 8 times 5.6? Is that all right?
Yeah.
8 times 5 is 40, and then 8 times 0.6 is like 4.8. So 40 plus 4.8 is 44.8.
I'm gonna go with 45.
But you
Yeah,
you
just
gotta
come
go-
up with something in the mid 40s and you've done it right. Yeah.
Wait, did you say we can't use calculators in GP?
On the multiple choice part, you cannot. That's why we do this.
Fair.
Yeah.
This isn't even math class.
Yeah, that's why we don't use our calculators.
Go back to fifth grade.
How are we doing here at 12:56? We got time. You got time?
No.
No.
Can we talk about one? It's not long.
It's not that bad.
No.
It's good to know how to do this.
What's a mono?
Find the molar mass of a what? Monoprotic? It's monoprotic. And what does monoprotic mean?
100.
It's an acid that has one hydrogen. The mono, oh yeah, it says right there. The mono means one. What does proton have to do with anything? Well, a hydrogen ion is just a proton. Because you know what hydrogen is. It's one proton with one electron around it. If it has become an ion, the one electron that it has leaves. What are you left with? A proton. So monoprotic means one hydrogen. Give me an example of a monoprotic acid. HCl. Give me an example of a diprotic acid. H2SO4, sure. Triprotic acid?
H3.
H3PO4.
H3PO4. Phosphoric acid.
No, one
Yeah.
Bite me.
Good. So we have a monoprotic acid that, given that 0.88 grams of the acid requires 20 ml of a 0.25 molar strontium hydroxide per Newton. What? Are you able to write a chemical equation for this reaction?
No.
Wait, yeah.
Yes.
What is the formula for this acid?
H. Then.
HX.
Yeah.
Call it HX. If it said it was diprotic, what would you put? You put H2X. Yeah. So if you have a problem that says you have an acid, you don't know what it is, call it HX. What's the other reactant? Let's see. Strontium hydroxide. Yeah. You know what the products are? Let's see if you know what you're doing here. What's one of the products? Somebody yell it out.
2H2.
Water. Oh, you want water. Okay, I like water. Because the hydrogen leaves that, goes with the hydroxide, you get water. What's the other product?
SRX.
2.
SRX2. What's the charge on X? If it's monoprotic, that means your positive ion charge is positive 1. Therefore, the X has to be negative 1. You with me?
Yeah.
So, strontium you know is a positive 2. Ooh, yeah.
Gotta add
Would
2.
we call it SR plus 2x? Because they're ions.
It may be insoluble. Doesn't matter. I mean, you could call it SR positive 2 plus 2x. Is it balanced?
No.
Nope. I think we need 2 of these to counter those, or to neutralize those 2 hydroxides and make 2 of those. Okay. Does this look like a stoichiometry problem to you?
No.
What are we trying to find here? We want molar mass. What do we know? We know there's 0.88 grams of this, and we know this, 20 ml and 0.25 molar. The question is, what is the molar mass of this? How would I find a molar mass, an unknown molar mass? How do you calculate molar mass? What do I need? Wesley, do you know? If I have the mass of HX and I have moles, then I could find molar mass. Because if this doesn't make sense to you, write this down. Molar mass, what's the unit on molar mass? Do you remember?
Grams.
It's grams per mole. Like 18. Water has a molar mass of 18. 18 what? 18 grams per mole. Every water mole has 18 grams. So if you can have a sample of something and you know how many grams it is and how many moles you have, which we'll be able to find in this problem, then you divide them and you get the molar mass.
Do you have 2 moles?
It's a 2 to 1 mole ratio. Doesn't necessarily mean I have 2 moles. But let's see, can we find the moles of this thing? I think we can. We have molarity, and we have volume. How many moles is this?
0.05.
How many zeros?
0.005.
That's right. Yep. This is 2 times 10 to the negative second liters. 0.02 milliliters, or liters, so that's 2 times 10 to the negative second. This is 2.5 times 10 to the negative first. So that times that is 5 times 10 to the negative third when you multiply those two together, which is the same thing as 0.005. How many moles of HX then do we have?
0.01. 0.01.
2 times that much. Yeah?
Yeah.
Yeah.
Yeah. So this 0.01, just take that first number of moles, multiply by 2, and you get that. Now, I have mass, I have moles, I can find the molar mass of HX. That's all it asks for. It doesn't ask you to identify what acid it is or what X is. Just find the molar mass of it.
87 grams.
What?
Is there anything with a molar mass of 87?
Yeah, it's probably some combination like an organic acid or whatever. What we were talking about earlier today. I don't know what combination of things gives a 87 per mole. Yeah, so the answer is 88 grams per mole. We're going to do a lab starting tomorrow that's much like this. I'm going to give you an acid. You're not going to know what it is, and you have to find its molar mass. Okay. It'll be fun.
It's intense.
That's not good.